So I'm Håkon. This is my presentation about code generation C++ with the GRC. First, I want to thank Martin for creating this icon, I suppose.
It took me a very long time.
So, this is my agenda. First, I will talk about the GRC. I suppose not everyone here has tried it. Then the C++ generation, how it works, and then what doesn't work yet. It's pretty much code. Most of it auto-generated, but still a lot of code needs to work. Then I will give a demonstration how to use it. So first, about me, shortly. I'm a student at the Department of Engineering Cybernetics at NTNU in Trondheim, Norway. They also kindly sponsored my trip here, so thanks for that. My involvement with the SDR in general started with this summer with the participation of ESA Summer Code for GNU Radio. And my task was to work with GRC and C++ generation with the GRC. So, GRC is a graphical tool to build applications with GNU Radio for SDR or DSP. You create flow graphs. It has been demonstrated in several of the presentations today. I suppose some of you have seen it. It uses the GRC file format, which is YAML, and currently it generates Python files until now, because my task was to make it generate C++ files as well. So, I'm going to start by showing you how it works. Really naive. Start with YAML blocks. Each block of the flow graph has its own file, which is the YAML file. It contains several things, but mostly it contains the parameters, which are the options that you can decide when you're creating the flow graph. And then the template, which is the code. So when you're generating a flow graph, you're just taking the parameters and filling them in the code wherever it's needed. Then this is fed into the Mako file, which then becomes a Python file, just by filling in all the blanks. So let's go a bit more top level. GRC creates Python files and can also, with my code, create C++ files. This generates, first of all, an empty build directory where the executable will live. And then it creates the cmakelist.txt and the source and header file. So, here's an excerpt from a YAML block. This is from the add block from grblocks. It's very simple. So the templates part, that's the Python code. And all the curly brackets with the dollar signs in front, that's where the parameters come in. And all of that becomes this line in the middle here for the Python code. For the C++ code, it's a little bit more complex, because you have several files and you have to declare types and so on. So for C++ templates, I have includes, which is just includes, goes in the header file. Then you have the declarations, which is the declaration of types, also goes in the header files. And then you have the make part, which is the make code, and that's basically just more or less the Python make, but with a semicolon at the end. So that's pretty simple. However, Python is a bit more simple than C++, so we have a couple of things that we need to add. That wasn't in this add block. First, we have the callbacks. It's just exactly the same as the Python code. And then we have link. Some of the blocks need to be linked at compile time. and we have to declare there which ones are going to be linked to what libraries. So that goes in the CMake files. And there's translations, which is wasn't really a plan to include that, but it became necessary. First of all, Python writes true and false with a big F and T. That became a problem. Also, the scope resolution operator is something that they don't have as a double colon in Python. So that was needed. So, what doesn't work yet? It's a matter of time, really. It will just take time, and then it will work. There's a lot of code that has to be parsed for me and translated. So the hierarchical blocks are something of an interesting feature with GRC. You can put blocks or flow graphs inside flow graphs, so to speak. And that's a bit more complicated, so I haven't finished that quite yet, but I'm pretty close. Then you have the Qt blocks, the frequency sinks, other types of sinks, and sliders, and so on. They also have a lot more code in them than the standard trivial blocks, so it takes a bit more time. And UHD also is pretty large. And there's more than 500 blocks, I believe, just in the standard GNU Radio installation, if you download it from GitHub. So that'll take some time, but I'm getting there. So now that we can use C++, we don't have to use Python anymore. No, unfortunately. At the moment, and I suppose it will always be like this, or what do I know, Python is easier for quick flow graphs and things like that in GNU Radio. If you just want to sketch up something and run it real fast, it's a lot simpler. But for perhaps embedded applications and applications where performance is of the essence, I believe C++ might be more interesting and more useful. So, I'm going to demonstrate GRC. Okay, so here we have a flow graph. It's extremely simple. You have a signal source, a throttle block, and then you have two sinks, the waterfall and the frequency sink. The first thing I want to mention is, if you see here, for those of you who are familiar with GRC, you can see that the output language is something new. So if you double-click that, here you see the options block. So this is where you put all the options that are specific for like the flow graph globally. And you can see here C++ is an option. That was just Python before. So you can choose C++. You can disable the CMake lists generation. If you have your own CMake files, CMake lists, you can use that. You can also pass options to the CMake. And you can choose between dynamic and static linking. Okay. So, two more blocks here. I haven't mentioned yet. It's the parameter block, which is command line parameters, standard with flags. And then you have the Qt GUI entry, which is just a tech line edit. So you can just enter a value, and it will change something. So, the entry block changes the frequency of the signal source here, and the parameter changes line width in the frequency sink, which is not exactly very useful, but it's okay for demonstrating. So now we have this flow graph. We've saved it. Then we generate it, pushing the button. Okay, it says generating. So now we've created a new directory. And let's see what's inside there. Okay, so here we have the build directory, CMake lists, and the source and header files. The build directory is empty for so long, but now we can press the execute button. There's CMake running. Now we have make running. And there we are. Okay, so this is generated completely right now from GRC in C++. Okay, and now we can change the frequency here. We're at 0 kilohertz right now, so we can set it to 3000. And then we see it changes both in the waterfall sync and frequency sync. So it works. Okay. And if we check the directory now, you can see that we have here the CMake files, a make file, and the executable. And we can check if the executable is built to the debug info. And yes, it is. This can be changed by changing this, for example. So you can add your own options there. Sorry. Right. Generate and make. Okay, so now it's without debug symbols. The last thing I want to show you is this parameter here, command line parameter. It says line width, and you can see here, we pass it as just width. So, if you go into the terminal again, you can try running demo FOSDEM with a help flag. Okay, so we need to pass width. Okay. Let's pass 4. Okay. And now you see the line width is significantly larger than last time I showed this. Okay, that's all. Thanks. Any questions? Yeah.
Could you try to compare with the static mode and see the size of the executable?
I can try.
Can you please repeat the question?
Yeah, sure. Okay, so the question is if I can compile with the static. Honestly, I'm not sure if it works with Qt static linking, but I'll see.
What's the current price at?
Right, current size. Okay, 204K. Make. Okay. Right. Yeah. That didn't work. I'm sorry.
You need to install static version of each line.
Yeah, sure. Yeah, that's right. Yes, please.
In the radio, it's not possible to use feedback currently. Do you envision that, well, with this you might be able to also create recursive filters, or if you spell out an IIR filter with recursive things that you can build it and directly generate C++ code?
Okay, so the question is if I will be able to, in the future,
Yeah.
I suppose, use feedback and, yeah, in the radio. To be honest, I think that's out of my scope, really. I'm sure everything is possible if you spend enough time on it, but yeah.
Can you just show the C++ code? I think that'll sort of clarify.
Yeah,
that.
sure.
Like while you pull it up, like the answer is that it'll generate C++ code that is it looks a lot like the Python code. It doesn't actually like put DSP into your C++. It doesn't instantiate all the blocks because the scheduler doesn't support the recursion like this will do the same thing.
Right, so this is the header file. It's pretty short. And then we have the source file here. Yeah. Other questions? Yes?
Could you just not necessarily compile an executable, but those shell objects?
Show objects.
Yeah. Here you generate a program,
Yes.
but why not generate a shell object .so?
Okay, all right, I see. So the question is, why not generate just the object and not the executable? I think you can pass arguments to CMake to do that, perhaps? I think so?
Yeah.
Yeah?
But would it be useful, right? Maybe for hierarchical blocks.
I suppose, yeah.
But if you're trying to run something.
Yeah, to use it in other programs.
Yeah, absolutely. Yes, please.
Did you actually do some profiling to check performance gains relative to the Python solution?
Okay, so the question is if I did some profiling to check the performance gains from Python to C++. No, I did not. Sorry.
They're not that big.
It's unlikely to make a difference. This is not a performance play. Every block is written in C++ anyways, so you're executing in a C++ world even when you're running in Python script. So
yeah.
This is if you don't want to execute Python and want to manage your source code in a different way, but not a performance play.
Yes.
How can people help you? You said you had this long list of things that you want to finish them. I mean, maybe you want to finish them all by yourself, but maybe you want people to help. And is there any way that people can contribute code or anything like that?
Okay, the question is how can people help me making this better and finishing it? Yeah, sure. People can translate blocks, but I suppose the most interesting and helpful thing for me would be if people tested it. It's up on GitHub. It's my fork. Perhaps should have a link somewhere. I don't, but I can fix that later in the slides. So yeah, please try it, clone it, download it, test it. It would be very well helpful. Yes, please.
So just to comment on Tom Ronald's, so if I understand properly, the objective here is to have an application that is self-sufficient to run on embedded electronics or embedded boards, as opposed to those having a Python virtual machine. Is this correct? Is the objective of generating the C++ to get rid of the dependency on the Python interpreter on embedded board? And the sequel to my question is, are you planning to integrate cross-compilation, or will cross-compilation be taken care of at the CMake step?
Okay, so the question is, the first question is the objective of compiling into C++ to avoid having to use Python? Yes, that is my understanding. And the second question was?
Well, most embedded boards will not have an x86 CPU. It will be ARM CPU.
Right.
So the question is, are we taking care of a cross-compilation from the CMake step, or do you plan when you well, of course, I'm just answering my question, because when you run exec, you will not be able to cross-compile on your CPU. So we have to cross-compile.
There is no target architecture in your...
No, I haven't. The question was cross-compiling. I haven't looked into that, sorry.
I mean, the CMake will take care of that for you.
Yeah, we pass the argument of preprocessor.
Yeah, it basically is you'll just tell CMake to use the cross-compiler, and GNU Radio out of the tree module stuff compiles fine that way.
But that opens the challenge of linking with the right library. Is this...
That's an understood problem.
Does GRC work with this? Can you run it on the command line, like turn the GRC file into C++ file?
Okay, the question is if GRC works. Yeah, I haven't tried it in a couple of months, but last time I did, it worked because GRC in itself is a very small Python program, and it basically just uses all the GRC code. So yeah.
So, like, to answer your question, then every cross-compile is different, right? So what you would then do, I assume, is like you would pull the GRC files into your compile chain, like like have a big CMake file that adds other parts of your project, pulls in the correct toolchain file, and then runs GRCC as an intermediate compilation step for before generating your SOs or your executables.
So GRCC is just a command line interface to GRC, really. Yeah.
Yeah, and I still think that there's a good conversation to be had to circumvent having to do a lot of that hand mod stuff. If you're using kind of a let's call it a recipe from an OE type system with a setup environment and all that, we could make it easier, I think.
Sure.
If you're using a standard approach.
Right.
Because I could also say, well, I could always just take the Python and copy it over and make my own C++ file. It's just that easy. But what we're trying to do is minimize as much work as possible to make this accessible for all these different platforms.
Yeah, I guess to solve all the possible problems, you would have to provide your own CMake template or something like that, right? Where
Right.
I mean, I guess you have a CMake template, right? That takes your source files and then does all the rest. And you could just like, okay, well, I'm not going to use the default template. I'm going to use this one that works across the other market.
Sure.
I like that we're having this discussion because we have some time to do so. So we have like 5 more minutes if anyone wants to ask a question. But if
Yeah, sure.
Just out of curiosity, do you have a plan to support embedded Python in it? So like we have these embedded Python blocks and you could embed it to like C++ and
Okay, so the question is, do I plan to support embedded Python?
Actually, like Mo had an embedded C++ block once because he played around with LLVM and was pretty happy. But I don't recommend doing that. It's not good for sanity, and everyone knows Mo.
Any more crazy ideas?
And by the way, this push to be able to generate C++ out of GRC was one of the reasons why I had a rule that no Python blocks were going into GNU Radio proper, because I did not want to have those kind of concerns or flaws when people did it accidentally.
Sure.
So if you're generating like a filter block and you generate the tabs, that's Python code if I get it right. Like the actual tabs is just a Python array. Have you tackled that?
So the taps. Could you repeat the question? Sorry.
Yeah, if you create tabs in a block.
Right.
Any
like an array, you mean?
Yeah.
Yeah.
How do you translate that to?
Yeah, parameters. You can. The question was, how do you translate Python arrays?
Oh, yeah, because you can do quite a bit of Python
Yes.
in those fields.
Yes. So if you have a parameter, if you put in a parameter block, a variable block, and you put an array as the value, it will be automatically translated to a C+ array. So that's handled, yes.
And if you use the FOSDEM notation.
What? Sorry.
FOSDEM, there's Python code to.
Oh, right, FOSDEM. If you use FOSDEM notation, I haven't looked into that. Sorry.
Yeah.
FOSDEM was translated to C++, so it should generate an STL vector.
Yeah.
Okay.
But I mean, that's basically the point where you can actually use help, because that's like a special case if you get a FOSDEM object.
Right.
There's a C++ equivalent, but
Right.
it's nothing that you can automate without the maintainer of that conversion knowing of. And I mean, that's something that the first time someone uses that could actually implement that. People
Right.
use that code, contribute fixes, contribute bug reports.
Yes.
So that's so sorry, my answer was probably a little too fast. So that is true for FOSDEM. Your question in a larger context is still true, that there's still a lot of Python utilities that may not be accessible in this, and I think that should be probably just tracked and converted over as much as possible to pure C implementation wrapped into Python for access there, but that we're not leaving anything out of that.
Okay. I think it's time to thank you.
Thanks.